My name is Jesse Cravens. I am an engineer at Frog. It's a global innovation company. We have our office here in San Francisco. I work out of the Austin office. I'm also the author of HTML5 Hacks, along with my co-author, Jeff Bertoff from Microsoft. Just released last week or so. 500 pages of HTML5 covering most of the major specs. JD Cravens is my Twitter handle. You see my GitHub account there, my website, and our blog for the book. So these are the 6 areas that I'm going to cover. Device access, client-side processing, device detection and descriptors, adaptive frameworks, HTML5 connectivity revolution, single runtime, and embedded JavaScript. All the code that you're going to see today is all hosted on GitHub. The HTML5 Hacks code, tons of information here. If you're in this space and you want to learn more about HTML5, Jeff and I, like I said, put together 590 hacks, 500 pages, and it's all there. You can see all the different specs from data, storage, geolocation, graphics, multimedia, CSS3. We also have a blog. So anytime we want to expand on something or add to it, it'll come out here, and the code will be back in the repository. The other thing I want to share with you is we'd love for you to join us. So if you're into hacking and you want to put together hacks, we'd love to have you join our community. Geolocation APIs, I'm going to show you some of that. It's probably one of the best entry points to device access. It's easy, simple API, and also it's got great support. So I'll be showing a demo on that. Device orientation, it's a little bit, I don't want to jump in any code there because we can get eaten up on that. Any of these topics could take up the entire time. But I do want to show you a neat little hack that we put together for device orientation and WebSockets, and that is not included in the book, so it's an additional hack. But overall, what I'm trying to show in these demonstrations is that the client's getting smarter. It's the device APIs are continuing to evolve, and we're getting more access to things like services applications such as the camera, microphones, system, sensors, so on and so forth. And then later on, when I show you the final demonstration, you'll get to see a microcontroller that's kind of speeding that up even further. So, just a quick, from caniuse.com, just a support spectrum here. Not sure about IE, where they're going with Git User Media. Something I wanted to ask you today, Jeff. But Chrome support has been very good. They opened up a couple releases ago. People are already starting to flood the web with different hacks and innovative solutions for Git User Media, and mixing them with sockets and everything. So, streaming. Geolocation, like I said, great support across the board. I'm going to show you a polyfill for 8.0, so that's also something that's included in the book. And then device orientation, like I said, we'll talk about it. I'll show you a little demo. It's pretty hacky right now. You got to do a lot to get normalization across browsers. That's just the state of where we are. So geolocation hacks. I'm going to jump over to the terminal. Very simple API. Does everybody see that okay? Basically, you've got this navigator, geolocation, get current position with a success and error object. You can then, inside your success function, you can go ahead and pass your position there. and get access to it. Down at the bottom, I'm logging it out to the browser, and you can see it there being logged. It didn't prompt me to ask for location because I'd already told it to, so it would normally do that. It's being cached. You can also do like a reverse geocode, where I take that and I call out to a Google service that's going to return a name. There we go. And the code for that, just kind of giving you an idea of what's available out there. We do a reverse geocode with the data, so I get my results back from Google. And then I've got to parse out this big object and pull out what I want. And I go ahead and I add it to the HTML, and that's what you saw there. Other things you can do is update map. So I can actually create an instance of a Google map, and where is that one? So on my success, I go ahead and instantiate Google Map, use the Google Maps API, and up at the top you'll see that I added the Google Maps API right here. And I have the document. Geolocate is a service I can call out to. It's a RESTful service, and they actually provide a socket server where I can pass in information. You'll see here. It's opening up a socket, and once it loads, you can actually move a marker being updated as the data is being funneled back to you through the socket. So we'll get into more of the HTML5 connectivity later, and I'll go through that. Let you know that this is IE8 here, where it doesn't work. You can see that I am actually getting the geolocation longitude and latitude there. And the way I'm doing that is using a framework called YupNope. If you haven't heard of it, it's a script loader framework that allows you to write rules so you can polyfill old browsers with code that doesn't exist in that browser. So IE8 doesn't support geolocation. This is a classic example of why you would want to use YupNope. Basically, it uses Modernizer, which is an object detection library. If it exists, if it doesn't exist, it's going to load this script. And that's what you're seeing. That's how I'm getting the longitude and latitude in IE8 in the emulator. I'm collecting device orientation data. And using something, an API really similar to what you just saw with geolocation. That's why I won't go into the code. But I'm pumping it over to another tab here. He's accessing basically he just gets a web page, it renders, and there's a library called Socket.io that is running on the server, and it's a polyfill library for sockets. So we're in a socket-supported browser here in Chrome, so you're seeing actual websites. And you can always see that by going into the console here. Sorry. Going in the Network tab, going into WebSockets, and you can now watch your sockets go back and forth. They don't update on their own, so you need to click to get an update. But basically what I'm doing is I'm passing the gamma, beta, and alpha data over through the socket and into the other browsers accessing it. And on the gamma data, which is actually, this has a device orientation built in, you can, when I turn it this way, it turns, when I turn it this way, it turns right. So I'm using a JavaScript library called Paper.js on the client side to do a simple canvas animation using the socket-powered data from the device orientation of the other tab. Next way that JavaScript is revolutionizing client-server relationship is through, it's because it's becoming more like a server in the way that it's handling processes, right? So the client-side background threads it's called web workers. How many of you have heard of web workers? Is that something? So basically, the JavaScript interpreter runs in a single-threaded event loop, and not before web workers, you weren't able to open up a thread and do background processing. So what would happen is if you did something that was long-lasting, it would freeze your browser, and you get an unresponsive script prompt, and you'd have to wait for that function to return before the event loop would move on to the next event handler. So browsers are implementing workers, and workers are getting used. The other thing is people are really embracing the asynchronous model and understanding how to utilize it. So even if you don't use workers, developers are starting to understand better and better how to use set timeout, other solutions to program asynchronously. And also we're seeing more reactionary systems. You're going to see more of this as I move forward. And then interpreters are maturing. Mostly, you hear a lot about V8. So the client's getting more powerful. Web Workers is very well supported, as you can see, except for in older versions of IE. And we're going to jump in. I'm just going to show you one of these. Image processing in a worker, firing off JSON P requests, doing a shared worker, which is actually accessing a worker script from different browser instances. And also another way to transfer data over to a worker or a background thread through transferable objects. But this is the idea. This is what I want to show you. So I put this canvas ball demonstration here to show you that the UI is very responsive. And what I'm going to do is I'm going to grab two numbers, and I'm going to process them and create a 2D array from them, which is an expensive computation, right? So if I do this without a web worker, let's see what happens. The ball's froze for a second. You saw that? If I increase the values, it's going to freeze longer. We'll run the risk of freezing up my browser, and then I'll take a while to get that fixed. But I'm going to do it with the worker, and I'll actually increase the values. And as I move the balls around the screen, I do it with the worker. You see the balls are still responsive, and then it processes complete. So what happened there was two scripts that are involved, right? So you have your main window that's running a script. Well, the way a worker works is it makes a reference and instantiates, this is the simple API right here, a new worker. You pass him the URL to the worker where that particular context exists, and it's in a different file. And then what I did there was I composed a little message of a JSON object, and then I post message it over after I stringify it, and then I set up an event to wait for it to come back. Okay, this is the way workers work. So the receiving script is sitting over here waiting for it. He's going to do all of our heavy computations. So when a message comes in, I've got a listener set up for a message to come in. I'm going to go ahead and parse that data, and then I'm going to do this nice little syntax hack, basically is what it is. I'm going to pull a comp function property out of the message that came across. And if you notice, you go back to the other, I said I want to do a create 2D array. So when he gets over there, he's looking for a function in this worker library called create 2D array at the top. So he passes the data in, does all the computation behind the scenes, and then he posts it back. Self-post message, computated back. It's really that simple. And that way, if you want to do any type of heavy computations, you do them in a different context in your browser. The main window browser where your application is running. This has tons of applications. Think about catching user events for analytics to image processing. Flickr does this with client-side image processing. And I have a nice hack in that example I showed you where You can take mouse events and actually process images in the worker. It has to do with responsive web design and adaptive frameworks and a combination of the two. Prior to my position at Frog, I worked for a big Fortune 100 company where we built a big enterprise framework that did the adaptiveness. So I'm pretty close to it, and I'm watching this space evolve. These are the different technologies that are present in a responsive application, responsive or adaptive. On the front end, you've got the concept of media queries, where the browser is actually querying the window and asking questions about it, and then making decisions based on that. And that's actually a CSS3 specification. You've got grids, which we didn't have before 6 or 7 years ago. We had table layouts, and then we had a lot of divs. Grids still use divs, but grids are nice because now I can kind of get pixel perfect locations within a UI. But they're also responsive in that if I want 3 columns on a smartphone and 12 columns on a desktop, I can configure that by doing the media query and then allowing my grid to adapt or respond to whatever device is calling the application. Modernizer is a object detection library that pulls the load of the page and basically creates a big hash map of all of the properties that are available, such as whether or not web workers are supported or any other specification. You can also tie into polyfill support. I showed you that in the geolocation. Adaptive frameworks are very much what Modernizer is in the browser, but it's on the server. And these have been around a while, but they're evolving, right? So think of a request comes in to an application, and I understand what the user agent string is, and I take the user agent string and I use it as a key to do a lookup in a big database or XML, basically just a big lookup table, to have it return to me everything that device, all the properties associated with that device. So whether it has camera access, what the size of the screen is, so on and so forth. So there's these repositories we call DDRs, or device descriptor repositories. And there was a working group, W3C working group. They closed in 2008. The artifact of that work was the DDR Simple API, which was then picked up by OpenDDR, which is a new project that spawned out of Wurfel going commercial in 2011. Wurfel was always the go-to. It was big XML, had tons of device data in it. Now it's commercial, and OpenDDR is the way to go. Thing is, right now, .NET and Java are the only two solutions that OpenDDR is providing. So there's a big opportunity in the JavaScript space to create an OpenDDR module for server-side JavaScript. Lysagless is a proprietary solution, and this is the solution that I use in the enterprise, along with Wurfel. What I'm going to do now is I'm going to show you a framework that makes the best. Let me just show you, sorry, real quick. I'll just jump over to it. A framework that I put together that takes the best of both worlds and utilizes them together. So, call it Responder.js. And it's a server-side adaptive framework that runs. It's a module for Node.js. I've written a lot of tests and included them in the package. And I want to hone in on that. I'm going to show you what exactly that means here in a second. Let's shut this down. Okay, so it's a very simple library right now. It's So these are for the test. These are just a bunch of user agents. So these are different types of devices. You got all these desktop browsers. You got tablets, smartphones, and large screens. And so if you're a business, no matter how big or small, you've got analytics that you've been collecting about your users or your customers or your members or whatever it is. And you know what's most important to you. And it's going to change over time. There's so much device fragmentation in the market that anybody who's not doing this and understanding what their users are using, they might want to start doing that, right? And the reason for that is testing all these devices is extremely expensive and complicated and resource intensive. So one of the things I came up with when I was in my last position was a graded device support model, where we use the analytics data to show what devices were most important. And then you can create a table. This is obviously very simplified. But you can create a table like this, whether it's XML or JSON or whatever. And you can say these are the ones that are most important, and it can change on a weekly, monthly, or whatever basis. The module is going to, so that's what I used for my test cases, right? And you saw, what I was showing out here is 8 of 49 are failing, right? So my framework is only 82% good. Right? There's actually 18% or so that, whatever that is, that are actually failing. That my framework says, I don't know what this user agent is, right? So the way it works is it's middleware. And to really demonstrate this correctly, I need to show you an application using it. Okay, so there's a lot going on here, but this is the framework's written where it doesn't have to tie itself to a front-end framework. The one this is a colleague of mine, Randall Elliott, created FN Responsive, and it's a really well-written front-end framework. So I decided to marry the two. What you'll see is this is kind of the basis of responsive. You'll see that the UI is changing, so if you were on a smartphone, you would get this UI. Tablet, probably something like this, and so forth, right? But, you know, doing everything in the client is not always the best idea because you've got a bunch of markup left over, you're probably loading a lot of scripts, images, and these devices need to be optimized for performance. So I want some control server side to be able to say, do not deliver certain artifacts down or assets down to the smart device, especially if it doesn't even use it, right? I only want him to get what he can use. So what I did is the framework right now is just printing out smartphone and desktop. It's really that simple. It's coming from the server. But it's a simple demonstration of now that I know what I am and what profile that I'm adhering to, I can go ahead and isolate my response from the server for that particular device. See down there that the request, profile of that request was desktop, and the profile of the other one was a smartphone. Based on these user agent strings. This one here is an iPhone, and this one here. HTML5 connectivity revolution and HTTP 2.0. So these are the new specifications that you're seeing in the HTTP space, or the connectivity space, I should say. We talked a little bit about WebSockets. I'm going to show you a demo in a second. XHR2, event source, service events, Speedy, cores. Speedy is, well, let me just start with XHR2 is the upgrade to formerly known as XHR. Event source is a browser-side object that can make a connection to a stream. Marries itself to server-side events. I have a great hack in the book on creating web-based push notifications using Sinatra on the server. And Speedy is a protocol by Google that is solving the problem of latency on networks by multiplexing and prioritization and some other networking optimizations. Very new, great book out called Speedy Book, speedybook.com. If you want to get in early on something and understand it early on before other people do, it's a good book to read. CORS is cross-origin resource requesting, or resource sharing. I have a good hack in the book on that about hosting a web font at Amazon and getting Firefox to actually make the request and receive the font. You have to go out to the server and configure it, whitelist it basically, so that you can make different domain requests from the browser. So Peter Lovers came up with this concept of HTML5 connectivity revolution is what he calls it. This is his diagram as well. You can see that the web page of the future is going to get constructed differently, right, than it is today. And a lot of them already are. In Chrome, you can actually see that a lot of their properties, maybe all of the properties, are being delivered by Speedy. There's a little plugin you can use to see it. Then you see service events, XHR2. I'm going to show you a great demo if you have time. XHR2, WebSockets, about to show you a demo. So basically, this is a collaborative presentation framework. It's got a system called, a library called Deck.js running on the client. And behind the scenes, there's a socket server. I'm also doing some geolocation there and putting that out to the screen. So if you hit this URL, it's going to find you. It's going to, so there's now 2 people on. It's going to iterate that counter, and it's going to update the UI in real time without refreshing the browser. The other thing I'm doing while y'all are doing that is I'm accessing a different URL in the same application. It's basically just going to send an XHR or XML HTTP request behind the scenes, hit the socket server, create an event, publish that event out to the 7 connected users that are all connected right now. This thing can grow to be pulling in Twitter feeds, to even using WebRTC for real-time data feed. I mean, there's lots you can do with this, but this is all very simple to create. It's all out on GitHub. Very small code base for what it does. But what I'll show you, hopefully this works. There we go. So it should have anybody who's logged on should have seen their browser go. To the next slide. Also, I put a Hello World Node Speedy library, somebody else's library. I put an example out there. If you just do a search for Node Speedy and kind of dig into it, there's a great little Hello World. If you want to get in and play around with Speedy, this is a great starting point.
Can I ask a quick question?
Yeah, go for it.
How supported is that on browsers?
Speedy? Actually, I have that right here. I didn't show you. If you go to caniuse.com, it shows you everything. Number 5, single language shared. What the problem is that the paradigms are still very different, right? You still can't take a UI developer who knows JavaScript very well and say, I want to make you a Node developer tomorrow. It's just not going to happen. The concepts are different. I/O is treated differently. Node streams are basically I/O as it should be, is the way I like to describe it. If any of you guys are Linux guys and you worked with Linux pipes, you'll pick this up really fast because basically everything is modular, and if you worked with Linux pipes, you do something and you pipe it to something else and something else. When it's done with this particular module, it moves on to the next one, and the syntax is really clean. It's the same concept with node streams. What we're going to witness here is all going to be I/O, server-side I/O. So I'm going to use the web browser to initiate the I/O, and it's all very simple examples. So when I bring this up, I've got a couple of text files. I've got 2 text files are empty. One of them called HTML5 hacks. The other one is out, and it's empty. And this one is full of a lot of interesting text. Node streams are actually called, or actually the technical term for it is chunk transfer encoding. So this is not unique to Node. You do this in any framework. Controllers here, the sixth way that I think that JavaScript is revolutionizing client-server interactions is through embedded JavaScript. So what I have here is an Arduino and a BeagleBone. So the Arduino, you're probably all familiar with what that is. It's a microcontroller. The BeagleBone is also a microcontroller that's running HDR Linux. It's a lot more robust. I've got access to everything that Linux provides. Here I'm fully connected to my machine, to my laptop. Here I'm connected over the network. Okay. There are a couple of library wrappers. I was going to show you Arduino, but it's not as important as Johnny 5. So we're going to focus on Johnny 5 real quick and BoneScript running on the BeagleBone. So what I want to do is I want to capture motion data here, and I'm going to pass it over to the BeagleBone through the network. I'm going to post it in an HTTP request. This is using JavaScript everywhere. Johnny 5 is giving me a JavaScript interface to interact with the Arduino. Okay? I don't have to write the C. Once I've uploaded my C sketch to this board, I get a JavaScript interface running on top of Node on my laptop. Here, I actually deploy out to here. I can pull from GitHub. I can secure copy over onto, just like you would on any remote Linux box. But I also don't have to have this connected to my machine. I can get a battery pack and I can get a wireless adapter here. It's fully mobile. And it's an actuator, just like this is, and it's also got digital in and digital out, is what I'm trying to say. The pins are also a lot more configurable. Here I'm kind of stuck in a rigid space. I can actually go in, because it is Linux, and I can configure these pins to use different types of input and output, different modes, crazy configurable. It's also very similar to the Raspberry Pi. You can do the same thing with the Raspberry Pi. I'm actually pushing data out to a Mongo cloud instance. And so that I can obviously do with this. Starting the app here, this is a Beagle server is what I call it, and it's also out on GitHub. My Beagle server is running. There we go. Okay, cool. This guy's still running. Yeah, there we go. So what it's doing is, through jobs, you'll notice that whenever a motion event, I got 3 different types of events that are coming in: a motion start and a motion end. And the Johnny 5 code, which I don't have up yet, but I've got the BoneScript code, is collecting the event, and it's going to go ahead and turn on the LED pin 2 whenever it's a start, and it's going to switch to the motion end, or the LED end 1, and the motion end event is called. So you can see here, yellow is capturing, it's passing it through the network, it's capturing any motion interaction. If the camera stands still, it's going to turn red. So, application of this, imagine Arduinos all in a circle around the room, passing information into a fully mobile micro network server that you can carry around and push data to the cloud. So that's the application. If you have any questions, I think we're probably out of time.